Thank you. It's great to be here today. It's a real pleasure to combine two of my favorite things, being in London and being in the warm sunshine. These aren't normally things that associate with each other, so it's nice to be able to have both of those here today. So I'm Rob Munro. I'm the CTO of Figure 8. I've actually only been with the company for about 10 months. I was a customer of the company for almost its whole 10-year existence, but just recently joined, having previously run some of the machine learning products that just got released on AWS. So happy to tell you more about Figure 8. So Figure 8, formerly known as Crowdflower, which might be a company name you're more familiar with. Our mission is to empower data scientists to train, test, and tune machine learning in a human world. So we produce the most widely used software for creating training data for machine learning, in addition to running the largest marketplace for creating annotations. So in the machine learning world, we are selling the picks and shovels that a lot of companies are using to ship their machine learning models. So if you have a car that parks itself, if your groceries are scanned somewhere between farm and table, if your news is personalized, then there's a really good chance that you're using machine learning that's being powered by Figure 8 in some way. And so in terms of the company size, we've been going for 10 years, working backwards from right to left here. In that time, we've collected more than 10 billion human judgments on data from machine learning. So for a self-driving car company, what is a pedestrian, what is a tree? For a social analytics company, what's positive sentiment, what's the name of a brand, et cetera. In computer vision alone, we've annotated objects or categories in more than 100 million images. And like I mentioned at the start, we have more than 100,000 people regularly working on our platform, creating training data from more than 150 countries worldwide. And our sweet spot is combining human and machine intelligence. So we certainly work with companies going from unstructured data through to deployed machine learning models that they use in their business. But our particular sweet spot is where there is a feedback loop, a human-in-the-loop process where we can combine human and machine intelligence to make a process happen much more accurately and much more efficiently. And we do this across a large number of use cases. So this is a screenshot from someone using our product for semantic segmentation for self-driving cars. So the way that a lot of self-driving car companies work, in fact most of them, is that they'll get images like this taken from the front of a car, and then someone, as if they're using Photoshop, is painting it and saying this is a road, this is a dividing line, this is a tree, this is a bridge. And then this semantic segmentation feeds their machine learning algorithms so that the self-driving cars can then do this identification in real time. We also do an increasing amount of computer vision work in agriculture. I find this to be a really exciting use case, given the efficiency gains you can get in agriculture, the reduction in fertilizer, and through both of those, a really positive impact in the environment. So in this particular case, helping companies automatically detect whether fruit are ripe. And we just had one of the companies using our technology had an article that did the rounds a couple of days ago, Riverbed Technologies, looking at how they can do computer vision to identify what's a sapling versus what's a weed, and automatically target just those weeds with pesticides. So really exciting uses combining computer vision with some of the world's most longest standing uses for mechanical technologies. And going from the macro level of drones on fields right down to the microscopic level, we work with a number of companies doing things like microscopy on oncology, so identifying cancerous versus non-cancerous cells, again combining humans and machines. And so our head of computer vision, when he was doing a postdoc at Harvard Medical School about 5 years ago, he'd written the first paper showing that crowdsourced workers with the right quality control can be as accurate as trained physicians in identifying cancerous versus non-cancerous cells And more recently, I was co-author one of the first papers showing that deep learning could more accurately and more consistently detect cancer than trained physicians. So it's a delight to be able to, among our use cases, help some which have a very immediate impact on the world. Another area that we work in which has an immediate impact on the world is in disaster response. So if any of you are here at 4:30 today, I'll be speaking on the ethics stage about AI for disaster response. So I actually used to work as a disaster responder for the UN in West Africa, moved to the US to get a PhD at Stanford focused on just this use case, and now it's a delight to be at the largest AI startup in San Francisco, supporting all kinds of use cases and being able to adapt that technology to disaster response. And so if there's any Russian, Arabic, or Mandarin Chinese speakers here, you can probably read what that says already. This is collected information about disease outbreaks globally across a large number of languages to help people track epidemics worldwide. And finally, we're also helping a lot of companies collect and manage their speech recognition data. So if you speak to your phone or your in-house device, chances are that's a customer of ours as well. And in a lot of cases, due to the workforce we have of more than 100,000 people worldwide, we're able to help them build out in languages which they haven't previously worked in before. So for one of the largest phone manufacturers, we're currently helping them expand beyond just single language to being able to support multiple languages at once. So most people, through most of history, have spoken more than one language, and we typically jump between those languages in the middle of a sentence. So anyone who's here multilingual know exactly what this is like. But AI is a little bit behind. At the moment, AI speech recognition systems have been trained solely in single languages, not allowing people to jump between the two. So it's wonderful to be able to help these companies move into the kinds of combinations of languages. Right now, looking at different combinations of languages across the Indian subcontinent, so that people can speak more naturally to their phones and in-house devices the same way that they speak to each other. And so I think a really good example of why we want to combine human and machine intelligence comes from self-driving cars and object tracking. So for a lot of different use cases, we're, as you can see here, trying to track specific objects in moving video. And you can imagine, right, if you're a self-driving car company, let's say you're collecting images from the front of a car driving down the street. So let's say there's 20 pedestrians and you've got just 10 seconds of video. At 30 frames a second, who can do the math on that of how many pedestrians you're identifying? So it's 20 pedestrians times 10 seconds times 30 frames a second. That's 6,000 individual boxes that someone would need to draw around each of those pedestrians in order to ensure that there's accurate training data. And if you look at an image like this, the amount of time it would take just to annotate a few seconds is prohibitive for a lot of companies wanting to train data on this. However, a lot of this is really redundant. So what we're able to do is use predictive bounding boxes to identify the objects that our customers care about, use video tracking to automatically follow those objects between frames, but then a human is still able to go in, scrub that video, and very quickly edit, delete, update any box, which is not accurate. So this means that we can get the same level of accuracy as you would get from humans doing the task manually, but we can get this with a 10 times speed up because of our integration of machine learning into the human annotation process. And this is where a lot of our particular benefits over especially in-house tools that customers previously used really come to light, this 10x improvement. And I think one of the nice things we can do as well is use our past images and use machine learning techniques like transfer learning in order to make this more efficient. So something you probably never thought about. So imagine you have 3 different people looking at the same image and drawing a box around, let's say like one particular car here. For quality control, you'll often give the same task to multiple people to ensure no errors propagate. So there's actually no shortcut mathematically if these 3 boxes aren't quite the same to combine them. There's no guarantee that the average box is the best one or the weighted average by the past accuracy of those humans. But this is something we can treat as a machine learning task in itself. So taking the 3 different boxes by the different humans for that one object, the past accuracy of those humans and the image itself, we can turn this into a machine learning task, which can much more accurately give that final bounding box. And what I love about this is that we're adapting this from the millions of past images we've seen that humans have manually labeled and the billions of CPU cycles that have gone into past machine learning models just to optimize the placement of one box for one self-driving car company. So it's a great way that we're transferring a very large and continually growing knowledge base that we have into much more efficient and much more accurate for the machine learning models for our clients going forward. And for those of you who are in the research community, we just announced some open source data sets that we've released on our website, including some interesting ones in disaster response, the topic that I said I'd be speaking about this afternoon. So this is a group of speakers of Swahili who are working with us in partnership with the Red Cross to create new audio recordings about health and disaster response related messages in Swahili so that the Red Cross can put this into apps which they're deploying in the region. And we can also share with our collaborators at Google and Microsoft so that their speech recognition and translation engines can be much more accurate in these languages for these particular use cases. So if you are in the research community, please have a look. These data sets are free and they're fun to work with. Okay, and I'm going to be around for questions afterwards. So if anyone can bear the heat in this room for a few minutes longer before lunch, I'd be happy to speak to you. Thank you.